This is example 2 on page 1 of section 1.5's notes, parametric and inverse functions. Example 2 is demonstrating how to eliminate the parameter or finding an XY relationship, algebraic relationship. So we're given the parametric equations where x is equal to t squared plus 2t and y is equal to t plus 1. So we're to find a set of xy points determined by this relationship, an algebraic relationship in terms of x and y, then graph. So a parametric equation is where you have both elements of an ordered pair that are defined in terms of another variable. And normally we use the letter t. So it's things like, those of you who are taking physics, it's things like having horizontal and vertical distance, and it's determined by time. And that's usually the relationships that we use are determined by an independent variable of time. So that's why our parameter is usually t. So what we want to do is we just want to substitute t into both relationships and then create our xy pairs. So I've already laid out the table and the t values, so I'm just going to fill those in. For first the x, if I substitute in the values -3 through 3, I get the following values. So I get 3, 0, -1, 0, 3, 8, 15. Then if I do the same thing for the y relationship, I'm going to substitute those same t values in. I'm going to get the following y values. I get -2, -1, 0, 1, 2, 3, and 4. So together they create our xy pairs. So we have 3, -2, we have 0, -1, we have -1, 0, we have 0, 1, 3, 2, 8, 3, and 15, 4. So that was the first part of this. Oops. So the next thing we're to do is we are going to create an algebraic relationship in terms of x and y and then graph. So we do that by solving one of the two equations, and it doesn't matter which one, for that third independent variable, t, and then substitute into the other algebraic relationship. So we're really solving a system of equations using substitution. So it works like this. So I'll go through the steps. So step 1 is you solve for t. And in this case, I'm going to use y equals t plus 1. Because the x relationship has a t squared and a t, and I actually have two different t values because it's quadratic. So the y relationship is much easier to get t by itself. So that's what I'm doing. So y minus 1 equals 2. And step 2 is to substitute for t in the second equation. In this case, it is the x equation. And I don't want to say the x equation because sometimes you might solve the x equation for t and then substitute into the y equation. So I know that x equals t squared plus 2t. So I'm going to replace this with y minus 1 squared plus 2 times y minus 1. Now I'm going to simplify this, so I'm going to expand y minus 1, and I'll get y squared minus 2y plus 1, and then the other relationship is 2y minus 2. Simplifying, I get y squared, oops, I said y squared, but then I wrote a 2. I get y squared minus 1. Now normally functions are written in terms y in terms of x, so I'm going to solve this for y. So I'll put that as the next step. Solve for y. Solve for y if necessary. because if you started out the other way and substituted into the y equation, you won't have to solve for y, it will already be solved. So my equation becomes x plus 1 equals y squared. So y is going to be plus or minus the square root of x plus 1. So that's my y. And what I notice is this is not a function, because each x is going to return two different y values, a positive and negative one. So it's not a function, because we're going to see when we graph it that we're going to have a function that fails the vertical line test. Okay, so plotting these points, going back to my xy pairs. So, and we can actually see it's not a function in the table as well, because if you notice, this x value 0 is repeated right there, and so is 3. So we have two places, and that would continue if we went beyond the values in the table. Okay, so now plotting those points, we have, I'll use red so you can see where the points are. We have a point at negative 1, 0. I don't know if I'll be able to get the point on there. It's kind of hard to put points on with this. Let me use a thicker pencil. I think this is thick. So I have negative 1, 0. Okay. That could be y. Sorry about that. Negative 1, 0. And then I have a point at 3, 2. And I also have a point at 0, negative 1. And I have one at 3, negative 2. And I have a point at 8, 3. And the other point I won't be able to get on because it's off the graph. But that's all right. This gives me a sideways parabola. And as I stated earlier, this is not a function. So that's how you change a parametric defined equation into an xy algebraically defined equation.